Thank you.
Thank you, Professor Lee.
Next will be Dr. Zhenzhao Li. Okay, please. And the topic is rack enhanced LLM for intuitive industrial robot control.
Good afternoon, everyone. I am Wu Yichen from National Formosa University. Today I'm going to introduce my research on robotic arm systems. The title of my presentation is Rack Enhancing LLM for Intuitive Industrial Robots Control. My presentation today will be divided into four main parts. To begin, let's look at the current landscape of industrial robotics. Currently, traditional industrial robotics face some challenge. Most robot deployment rely heavily on manual programming, which is not only time-consuming but also costly. Furthermore, these robots are often decided as static systems, meaning they don't have the flexibility to adapt to dynamic or changing environments. To improve efficiency, we must develop a faster and more flexible way to control robots in modern industrial settings. To address this issue, the current trend is to integrate generative AI and large language models to make human-robot interaction more intuitive. However, we face a major challenge. LLMs often suffer from hallucination, where they generate incorrect or even unsafe comments. Therefore, my research goal is to develop a reliable system. They can safely transform AI-generated ideas into real-world robot actions. Now, let's move to the research method. Moving on to our objective, we use retrieval augmented generation to stop AI hallucination. This allows us to achieve conversation as programming. When simply talk to a robot replaces complex coding. And we built and integrate HMI. This interface combines waypoint management, voice input, and text planning into one simplest platform. Here's the technical overview of our system, showing how we achieve reliable robot control through four main parts. And step one, the process begins when the user gives a natural language comment. We use OpenAI Whisper to convert the spoken instruction into accurate text. And step two, to solve the hallucination problem, we integrate anything LLM. Think of it as a librarian for our robots. When a user gives a comment, anything LLM quickly look up two things in its library. First, the user manual is find the safety rules. Second, sample program is find a correct code template. And by giving this space to the AI, we ensure the code is always safe and perfect for our universal robot. Our system prompt defines the AI roles as you are robotic expert. It uses a vector store to reference user manuals, ensuring the text plan is accurate and not hallucination. Step 3. The LLM breaks the text into logical subtext and generate exact Python code for your robot, such as move L commands and prepare action. The generated code is sent via a RESTful API to our Python control system. The system that communicates with the robot motion controller over a TCP/IP socket safely start the movement on the robotic arm. Now, let's look at the result. In industrial tech, some positions are used very often. With our system, you can save and manage this target point easily. For example, you can save the point as P1 or home. Next time, you don't need to give the full coordinates. You can just move the arm to point A. This makes controlling the robot much faster. And in the video now, I'm setting the first point. I can change the movement distance by input the number. So I can control it, and I will set the point will be P1. And the next point will be P2. Okay, let's move on. Now, let's talk about voice input.
Move the object from P1 to P2. Hold at 20 centimeter to target 1 second before bringing.
And the voice will be on the PowerPoint. Okay, now let's talk about the voice input and your screen automation. First, voice processing. We use the whisper model to exchange the user voice into text comment. Second, text planning. This is a brand of our system. We define a role for AI as a robot expert. To make the robot understand, we force the AI to output the JSON format. This is structure list that include the action type and target description. This ensures the robot knows exactly what to do without any confusion. And now we reach the final flow, running the comment. Once the AI generates the text list, the robot starts to move. It follows the JSON instruction step by step. The robot runs the UR script automatically. As you can see, the robot moves safely and accurately based on the user comment. In summary, our research has two main achievements. First, we successfully combined LLM and RAG. This proved that talking to the robot is both possible and reliable. Second, we create a context-aware environment. The robot is become a smarter and safer partner for humans. For our future work, we have three goals. We will use the YOLO framework so the robot can see and avoid obstacles. And we want to support more robot breed like Kuga and Phoenix. And we will optimize local LLMs so the system can work perfectly without the internet. And that is all of my talk today. Thank you very much.
Okay, thank you. Actually, this is a very amazing system because, and I know coding is very hard for maybe not designed based people, and you just created a system and to help the people to write code.
Yeah.
And so, did you have any tests for the people who don't have learned the coding before or not?
The text?
For the coding.
Sorry, can you repeat that again?
Okay, some people who don't have learned the code before.
Yes.
And so, have you tried to find some people who use the system?
Not yet.
Okay. Okay. So, and your demonstration is focused on robotic arms.
Yeah.
So, did you control another robot by using this system?
Maybe future I will use this system to control PLC.
Yes.
Yeah, I will try it.
Okay. So, do you have any plan in the future for control everything or coding another?
Equipment.
Yes.
Another.
I will try to control different brand of
Yes.
robotic arm
Yes,
or
yes.
PLC
Yes, or
to
something.
make difference.
Sure. Not yet? Yes, okay. Is your lab due?
Master, this is an undergraduate project?
Yeah, this is my
Okay.
project.
Okay, that's amazing.
Thank you very much.
Very
Thank
good,
you.
very good.
Okay, some questions or comments? Okay, thank you. Okay, the next will be Miss Hong Yi Lee, and her topic is designed in effective digital interpretations of Taiwanese